What's this?
The voltmeter on the right is the input voltage, and the voltmeter on the left is the charging voltage.
That's right.
So we have over unity right here.
Yeah,
Plus we have
15,
this
6 and 12 on the empty battery entry. You have an exit on the second winding going on the battery.
Yep. So here's the setup. This is a bifiller coil. We see the two wires. One is a thick gauge 23. Well, it's not thick. It's just thicker than the 26 gauge, which is the 26 gauge comes from the input power,
23.
and the 23 is on the other bifiller coil, other part of the bifiller coil, which is going into this charging battery, and the charging battery voltage is showing 15.56 volts. And the charging battery, the discharging battery is 12.17. Now this is the oscilloscope shot. See the spikes of radiant energy being created without any motion.
No, you don't see the radiant energy. You're going to see it after I disconnect.
Okay, you don't see radiant energy now.
Now you're going to see the spike.
Roger's going to disconnect. Whoa.
You see that?
No, do it again. Okay, it's very faint on that. It's just.
I'm going to burn the transistor.
Okay, fine.
I'll try to lower the signal as much as possible. Make it. Okay. Okay. Now you're going to see the signal go absolutely go off the scale.
Oh wow, that's just from disconnecting the charging battery.
Look at the circuit. You will see the neon light. This is radiant energy actually being produced.
Wow.
I can't keep it too long because I'm going to
burn.
The transistor cannot. You see the transistor is already vibrating.
Now what? That's amazing. Now what we're going to do next is we're going to charge a mojo cell with the radiant energy that's coming off, and instead of going straight to a battery with this charging voltage and these huge voltage spikes, as we see on the oscilloscope, we're going to charge a mojo.
As the magnet is passing across, is interfering.
Yeah, the magnet is actually, and this is the original schoolgirl experiment, but now, because there is a solid state setup, with the transistor has an increased resistance to cause it to oscillate.
That's right.
So it becomes solid state. It doesn't even need the motion of the magnets, and the magnets are actually deterring from the voltage. Although we lost the, can you get that spinning again?
Yeah, it's spinning, but look at the interference it's making.
Wow. On the oscilloscope shot, you really see it distorting.
It goes absolutely off the scale.
What are you doing now with that potentiometer? Are you tuning?
I'm increasing the resistance to get the transistor oscillation. To get the highest possible voltage output.
Wow. What is that?
15 volt.
Okay, 15 volts now? That's not even as high.
Are off the scale.
Wow.
Look at that.
Wow. But is this going to lose momentum or keep spinning?
Yeah, it is, because I put it on the highest possible. So the most of the, I'm keeping the most of the residual voltage.
But it will spin now. It won't stop spinning.
But the spinning is not really necessary.
No, because you have
a solid state. This was just originally when I had no, you can put it as original project. You would not have to. You see the difference in spikes.
Yeah. So we want to put it back to the original one now. Okay.
Schoolgirl project. This is pure Bedini, the radiant energy creation. But you'll see here the radiant energy now is not produced as in a big amount. See, now you can run it. Okay, it's not as much.
Yeah, but that's some spike there. How many volts do you estimate on the peak there?
I cannot measure the. It's the highest that my scope can handle.
Okay, take a wild guess.
I would say around 350 to maybe up to 700 volt. But I cannot measure, because if I keep it off to do the measurement, my transistor is going to just burn up.
Okay.
You can't handle the.
All right. So what do you say we put the mojo as the load? No. Okay. Okay.
Because of the we are not taking consideration amperage.
And is it possible to switch them into amp meters?
I only one. That's why I wanted my friend to.
This is a pure Bedini schoolgirl project now because we took off the extra resistor that was creating a natural oscillation in the transistor, which is what we'll call solid state. We'll even get more created voltage, more radiant energy out of the solid state than this, but this is kind of more exciting to see because it's all these moving parts and stuff. Although that's we can get past that pretty quick.
There we go.
So now Roger just tuned the output voltage for optimal voltage. This is over unity right here. We're creating more than we are putting in, and we have all this free movement.
Movement is absolutely free.
Movement is free.
Yep.
So if you calculate the wattage that's being used to move it, and you add to this, you can see the percentage will be more than it's hard to say, more than maybe 150%.
I have to do precise calculation to be able to answer you the exact question.
Beautiful spikes there.